Okay people, in this video on functions, we're going to be learning about functions with two unknown coefficients. And to be more specific, we're going to be learning how to find those two unknown coefficients. And for that, we'll be working through the two examples that we see on the screen here. We can see right away that in each case we have a function which has two unknown coefficients. And let me say that regardless of the type of function that we're dealing with, so whether it be a cubic function, a rational function, a quadratic function, or a linear function, the method we learn about here can be used for any type of function. All that being said, let's get started. In this first example, example 1, we're told that the curve y equals to ax cubed minus 6x squared plus cx plus 18 passes through the points with coordinates 2, negative 12, and negative 1, 24. And we need to find the coefficients a and c. So those are the x cubed coefficient, that's a, and the x coefficient, which is c. And as I usually do, let me start by writing SOL here for solution. Now the trick we learn about here can be summarized as follows. Since we have two unknown coefficients in our function, we're going to need the coordinates of 2 points through which the curve passes. And that's exactly what we're given. Indeed, we have the coordinates of one point here, 2, negative 12, and we have the coordinates of another point right here, negative 1, 24. Using the coordinates of each of these 2 points alongside the function's equation here, we're going to derive two equations involving the two unknown coefficients, a and c. And here's how. I'll start with this first point here, with coordinates 2, negative 12. Since the curve passes through this point, that tells us that if we replace every single x we have inside this function's equation by 2, then we'll have to replace the y we have on the left-hand side here by negative 12. So let's go ahead and do that. I'll replace the y by negative 12, so negative 12, and that should equal to a times the x coordinate cubed, so 2 cubed, minus 6 times x squared, so that will be 6 times 2 squared, plus c times 2 plus 18. I now tidy that up a bit. That's negative 12, which equals to a times 2 cubed, which is 8, so a times 8, minus 6 times 2 squared, which is 4, plus c times 2, which is just 2c, plus 18. I carry on. That becomes negative 12, which equals to a times 8, which is 8a, minus 6 times 4, so that's minus 24, plus 2c, plus 18. I carry on, and on the right-hand side here, we have negative 24 and this 18 that's being added at the end here. So gathering those two things together, we'll have negative 24 plus 18, which is negative 6. And so let me write that. That's negative 12, which equals to 8a plus 2c minus 6. Now I make sure that the two unknowns, a and c, are alone on one side of the equation, and for that I'll get rid of this 6 that's being subtracted from the right-hand side, and I do so by adding 6 to both sides of this equation. And so on the left-hand side I'll have negative 12 plus 6, which is negative 6, and on the right-hand side I'll have 8a plus 2c minus 6 plus 6, so that's just 0. We're nearly there. I now notice that every single term we have here has a factor of 2, and so dividing throughout by 2, this becomes negative 3, which equals to 4a plus c, which I could rewrite as 4a plus c equals to negative 3. In fact, I'll quickly do that here. That's 4a plus c equals to negative 3. Done. We now have one equation involving the two unknown coefficients a and c, and I'll call that equation E1. Okay, now that I've used the first point that we had, 2, negative 12, I turn over to the second point we were given, negative 1, 24. And in a similar way, I'll replace every x I have inside my function's equation by negative 1, and I'll replace the y on the left-hand side here by 24. And that leads us to a second equation, 24, which equals to a times negative 1 cubed, minus 6 times negative 1 squared, plus c times negative 1 plus 18. I carry on, that's 24, which equals to a times negative 1 cubed, but since negative 1 raised to the power of 3 is just negative 1, that turns into negative 1 times a, which is just negative a, And we then have negative 6 times negative 1 in parentheses squared, Well, negative 1 in parentheses squared is 1, so that turns into negative 6 times 1, which is just negative 6, or 6 that's being subtracted. And we then add to that c times negative 1, which is just minus c, and we have plus 18 at the end. Now on the right-hand side, I gather this 6 that's being subtracted with the 18 that's being added, which quickly turns into negative 6 plus 18, which is 12. So we have 24 equals to negative a minus c plus 12. I now get rid of the 12 that's being added on the right-hand side here, and I do so by subtracting 12 from both sides. So I'll have 24 minus 12 on the left-hand side, which leaves us with 12, and that's equal to negative a minus c plus 12 minus the 12 we're subtracting, so that's just 0. And now rearranging all of this so that the a and the c appear on the left-hand side of the equation, this quickly turns into a plus c equals to negative 12. And that's our second equation involving the unknown coefficients a and c. So, at this stage we have two equations, equation 1 and equation 2, and both of them involve the unknowns a and c. And so now to find a and c, all we have to do is solve this pair of simultaneous equations. And so let me quickly copy those. I have 4a plus c equals to negative 3, that's equation 1. And we have a plus c equals to negative 12, that's equation 2. Looking at these two equations, I quickly notice that they both have one c inside them. And so to get rid of the c's, I'll subtract e2 from e1. And so let me just write that so I keep track of what I do. I'll do e1 minus e2. So let's see, that turns into 4a minus a, which is just 3a. And we then have c minus c, which of course is 0, so we've eliminated the unknown c. And so that will equal to the right-hand side, so we'll have negative 3 minus negative 12. And negative 3 minus negative 12, well, that's negative 3 plus 12. So negative 3 plus 12 turns into 9. Next, since 3 times a equals to 9, we can figure out what a is by dividing both sides by 3, which quickly tells us that a equals to 9 divided by 3, which is 3. And we now have one of the two unknown coefficients. And so to find the other unknown coefficient, I turn back to either one of the two equations we started off with, and I'll choose the second one we have here, e2, and I replace the a we see by the value 3 we just found, and I'll solve for c. And so let me just quickly do that up here. There we go. I'll say using e2, I replace the a that I have here by 3, so that it becomes 3 plus c equals to negative 12. And so subtracting 3 from both sides, we quickly find that c equals to negative 12 minus 3, which is negative 15. And we now have the second unknown coefficient. And so now that we know what a and c are, we can rewrite this function's actual equation. Indeed, we can now state that y is equal to 3x cubed, since we found that a is equal to 3, minus 6x squared, minus 15x, since c equals to negative 15, plus 18. And I'll even box that result. There we go. Okay, now the good news is the method we've just seen here works for any type of function. And to confirm that, let's go ahead and work through example 2, and I'll just make a vertical line to separate things. There we go. And in example 2, we're told, given the curve of f of x, which equals to ax minus 2 over x plus b, passes through the points 2, 8 and 4, 6, find a and b. Okay, well again, I'll start by writing SOL here for solution. And anytime I'm given a function like f of x equals to ax minus 2 over x plus b, what I like to start by doing is rewriting that as y equals to ax minus 2 over x plus b. Just to remind myself that the y is on the left-hand side here. So that's y equals to ax minus 2 over x plus b. Okay, once more, since we have two unknown coefficients, we need 2 points through which the curve passes. And again, that's exactly what we're given. Indeed, we're told that the curve passes through the point with coordinates 2, 8, and that it passes through the point with coordinates 4, 6. And so using the x and y coordinates of each of these 2 points alongside this curve's equation, we can derive two equations involving the two unknowns a and b. So let's go ahead. I'll start with the first one here with coordinates 2, 8. Since this curve passes through the point with coordinates 2, 8, that tells us that if we replace the x's we have here by 2, then we must replace the y that we have on the left-hand side by 8. And so if I do that, that would be 8 equals to a times 2 minus 2 over 2 plus b. Now I need to rearrange this so that I end up with an equation looking like the ones we had in example 1 here. And for that, I need to get this b away from the denominator. And since 2 plus b is dividing this numerator, to get the b away from there, I'm going to multiply both sides by 2 plus b. Or put simply, this 2 plus b comes to multiply the 8 that we have on the left-hand side. So that would look like this. We'd have 8 times, in parentheses, 2 plus b, which equals to the numerator we have here, which is a times 2, so that's 2a minus 2. So I'll just quickly write that. That's 2a minus 2. I now distribute this 8 across this pair of parentheses, which leads to 8 times 2, which is 16, plus 8 times b, so that's 8b, and that's equal to 2a minus 2. Now I want to rearrange this so that the a and the b appear on one side of the equation, and any constant appears on the other. And so for that, I'll start by getting rid of this 2 that's being subtracted from the right-hand side, and I'll do that by adding 2 to both sides. So we'll have 16 plus 2 on the left-hand side, so that's 18. So that's 18 plus 8b equals to 2a. And I'll now get rid of this 8b that's being added to the left-hand side, and I'll do so by subtracting 8b from both sides of this equation. So that quickly turns into 18 equals to 2a minus 8b. I now notice that every single term has a common factor of 2, so I divide throughout by 2, which leads to 9 equals to a minus 4b, which I'll rewrite as a minus 4b equals to 9. So let me quickly do that. That's a minus 4b equals to 9. And that's my first equation involving the unknowns a and b. Okay, now that we've used this first point, we turn over to the second point we were given, with coordinates 4, 6. And so, in a similar way, if I replace the x's we have inside this equation by 4, then we have to replace the y that we have here by 6. So we can do that up here. That's 6 equals to a times 4, so that's 4a. So let me just write that. That's 4a, and that's minus 2 on the numerator, over 4 plus b. I now multiply both sides of this equation by 4 plus b, so that we get 6 times, in parentheses, 4 plus b, which equals to 4a minus 2. I now distribute this 6 across this pair of parentheses, which leads us to 6 times 4, which is 24, plus 6 times b, so that's 6b, and that's equal to 4a minus 2. Again, I now rearrange all of this, and so I'll get rid of this 2 that's being subtracted from the right-hand side, which I do by adding 2 to both sides of this equation. So we have 26 plus 6b equals to 4a, and I now get rid of this 6b that's being added on the left-hand side, and I do so by subtracting 6b from both sides of this equation. And so we get 26 equals to 4a minus 6b, and again, I notice that all of the terms we have here have a common factor of 2, so I'll divide everything by 2 to write 13 equals to 2a minus 3b. And I'll rewrite this as 2a minus 3b equals to 13. And here that is, that's 2a minus 3b equals to 13. And that's our second equation involving the two unknowns a and b. So I'll call that E2. Okay, now at this stage, to find a and b, all we have to do is solve this pair of simultaneous equations. And so if I quickly copy those equations here, we have E1, which is a minus 4b equals to 9. That's E1. And we have E2, which is 2a minus 3b equals to 13. There we go, that's E2. Now to solve these, we could of course use the method of elimination, which is what we did earlier on here, or we could also use the method of substitution. And this time around, I think I'll do that. And so using the first equation, E1, I'll rearrange this to make a the subject. Indeed, starting from a minus 4b equals to 9, we can quickly add 4b to both sides of that equation to state that a is equal to 4b plus 9. And in fact, I'll go ahead and box that. That's the expression we got for a using equation 1. Now, using this result and going to the other equation, so E2, we're going to replace the a that we have inside E2 by 4b plus 9. And so let me just keep track of that. Now we now turn to E2, so that's the other equation. And so that becomes 2 times, in parentheses, 4b plus 9 minus 3b equals to 13. And now distributing this 2 across that pair of parentheses, we quickly find 2 times 4b, so that's 8b, plus 2 times 9, which is 18, minus 3b equals to 13. And gathering the b's that we have on the left-hand side here, we have 8b minus 3b, which is 5b. So that's 5b plus 18 equals to 13. And we now get rid of this 18 that's being added on the left-hand side here. And we do so by subtracting 18 from both sides. And so we're left with 5b plus 18 minus 18, which is just 5b, which equals to 13 minus 18, which is negative 5. Finally, we have 5b, or 5 times b, which equals to negative 5. And so dividing both sides of this equation by 5, we quickly find that b is equal to negative 5 divided by 5, which is negative 1. And we've now found one of the 2 unknown coefficients. And now that we have, we go back to the expression that we had boxed earlier on. That's a equals to 4b plus 9, but we replace the b that we have here by negative 1. And so let me quickly write that. I go back to E1. There we go. And so that was a, which equals to 4b, so that's 4 times negative 1, plus 9. Now, 4 times negative 1 is negative 4, and negative 4 plus 9, well, that's 5. So we can state a equals to 5. And we're done. We've now found both of the unknown coefficients. And so to finish, we could rewrite our function's equation, replacing the a and the b by the values we just found. In fact, I'll do that at the top here. We can now state that y is equal to ax minus 2, so that becomes 5x minus 2, over x plus b, so that's x plus negative 1. In other words, that's x minus 1. And I'll go ahead and box that result. There we go. And there we have it. That's how we can deal with functions with 2 unknown coefficients using the x and y coordinates of 2 points through which the curve passes. And with that said, I really hope this video helped, and if it did, please hit like on this video, drop a comment down below, and even subscribe to this channel, because that really will help this video reach as many students as possible. All that being said, that's it for this tutorial.